In today's class, we're going to take a look at finding the derivative of more complex functions. We've been taking the derivative of simple functions for quite a while. The rules that we've learned have served us very well. But what about more difficult or more complex functions? Well, there are other ways of taking the derivative that make it easier rather than trying to get it into the form that we could use with our more simple functions. Now, that being said, here is actually a simple function. And we could look at this as a function y, and it's made up of two smaller functions. That's a little strange way to look at this, but we will look at this in this section. That it really is one function, but we could say that the one function is made up of the function that's inside the first set of parentheses here, the 2x cubed minus 5x. And the second function would be what's inside the second set of parentheses, namely the 3x plus 1. Now, using our rules that we've learned already, we could say, well, this would be easy just to multiply out. If we multiplied it out, we would get this. And if we take the derivative of this, we would get 24x cubed plus 6x squared minus 30x minus 5. And this works very well. In fact, this is an easy way to do it for this one. But what if we had a more complex function like this, where we wanted to find the derivative of this y function, and it's made up of two equations multiplied together? Well, we know if we wanted to multiply this out, this would take a long time. It's going to be x squared minus 1 times itself 4 times. Well, that's going to give us an x to the 8th plus or minus a number of x to the 6th, a number of x to the 4th, x squared, and then of course a plus 1. And this one is going to be x squared plus 1 times itself 5 times. Well, that's going to give us an x to the 10th, and multiple x to the 8ths and x to the 6ths and 4ths and so on. And then when we get that, we have to multiply these two together. Well, that would take an incredibly long time. Maybe there's a shorter way. And there is. It's called the product rule. The product rule is simply a formula that if you want to find the derivative of two functions multiplied together, it's going to be, now when I say two functions multiplied together, remember, this f of x could be just like this first equation, x squared minus 1 to the 4th power. That's the first equation. And g would be the second one, the x squared plus 1 quantity closed to the 5th power. And when we do that, we realize we have the two functions, f and a g. It would be the first function times the derivative of the second function, or the second set of parentheses, plus the second function times the derivative of the first function. Now, when we're doing this, we'd say we're doing an f of x times a g prime of x plus g of x times f prime of x. And in reality, to make it easier to memorize, usually what I tell students is, don't always write the x's. We know that they're supposed to be there, but if you're going to memorize it, then just think, when you want to take the derivative of a function, there's two things multiplied together, it's f times g prime plus g times f prime. Now, when we're doing this, we realize, well, the order of this isn't really that important when you're simply adding something together. So realistically, we could also look at it as g of x times f prime of x plus f of x times g prime of x. And we realize it's just simply changing the order of this one. And the same with the shortcut, the thing for memorizing, g f prime plus f g prime. It's simply reversing the order of this one. I mentioned this because two reasons. One, the book uses this, and so I also teach it this way. So the answers will be in this kind of format as well. But when we get on to the quotient rule, which we will shortly, even though it is very different, there are some similarities in the order of the terms if you memorize this one this way. You'll see that shortly. So you can memorize it either way. They actually mean the same thing. The order is not important. Memorize it in whichever way you prefer. Now, using our simple function, if we were going to differentiate y, again, we did that by multiplying out and taking the derivative. We'll get the same answer if we use the product rule with this. What we do first is we identify which is our f and our g. Again, whatever's in the first set of parentheses is our f, and the second one is g. Once we do that, we know we also need an f prime and a g prime for this formula. So we identify our f is this one, our g is this one. Then we take the derivative of f, and again that's going to be 6x squared minus 5. And we take the derivative of g, which is going to be 3. Now, putting it in this form is a helpful thing. It helps keep it straight. Now we can simply take this and plug it into the formula. I do encourage you to get used to this. As on the exam, I give credit for showing me this. Two things it does. It helps me know that you know what you're doing, and it also just makes things a little bit easier to read when I'm going through your work when grading. It's clear what is your f and what is your g. If you made a small mistake somewhere, it's easier for me to identify and I can give more points. So if you get used to this, it's a helpful thing. Now, if we put this into our formula, of course, our f, the first one, is 2x cubed minus 5, and our g prime is 3. So that's the first one, plus g, which is 3x plus 1, times f prime, which is 6x squared minus 5. Now, we don't see any common terms in there, so we just do the multiplication. 2x cubed minus 5x times 3 is going to be 6x cubed minus 15x, and then using, I think, the FOIL method here to multiply this out, we get this. Now, we combine all the like terms, and we end up getting the same answer that we did before. Again, for simple ones like this, it's probably easier just to multiply it out and take the derivative, but we're going to get into more complex ones where you really don't want to multiply it out. And again, back to the example that we had before. If we have this one, what we need to do is identify our f and our g. Now I'm going to switch to my other utility simply because I need more board space. And when we do this, our f is going to be the first one, and our g is the second one. So we define f as x squared minus 1 to the 4th power, and our g is x squared plus 1 to the 5th power. Now, we take the derivative of each one. So f prime is going to be 4 times x squared minus 1 to 1 less power, the third, times what's inside of the parentheses. You take the derivative of what's inside the parentheses. So that's going to be 2x. And we do the same with our g. Our g prime is going to be 5 times, again, x squared plus 1 to 1 less power, times the derivative of what's inside, and again, that's 2x. Now, we use our formula. We're going to use our f g prime plus g f prime, and that's going to be, well, we take our f. Our f is x squared minus 1 to the 4th, and we multiply that by our g prime, and that is 5. X squared plus 1 to the 4th power times 2x. Now, we're going to add to that g, which is x squared plus 1 to the 5th power, and we multiply that by f prime, which is 4 x squared minus 1 to the 3rd times 2x. Now, what you'll notice when I took the derivative of f and g, I left the terms exactly as we do in the setup. I didn't combine anything together. I didn't say that the 4 and the 2x is 8x, and that the 5 and the 2x is 10x. Well, I did that for a reason. When we get down here, it helps us to see terms that we can factor out first. The tendency is to look at this and say, well, to get to the answer, I have to multiply all this stuff together. Ooh, that's going to take some time. And then I can put them together. And then once I add them together, I'm supposed to also factor out common terms to make it simplified, to make it easier. Oh, that's hard to do, right? Well, we can make it easier if When we get to this step, if we leave everything in its basic form, just like I just did, then we can factor out the common terms first, when we know what they are. And by that, I mean, let's look for what is a common term here. We quickly see, well, 2x is here and here. When we're factoring it out, realize that a way of looking at this is saying that here, this is all one term to the plus sign, and then the second term is all of this, everything that comes after the plus sign. We factor something out of each of these, we'll put them before this kind of thing, before the big set of parentheses. So we'll factor these out, and we look at it and we say, oh, but there is also here, we have an x squared minus 1, and there's also an x squared minus 1 over here. And we realize there's also an x squared plus 1 and an x squared plus 1 here. So we have 3 terms that we can factor out before we multiply it. That'll make things much easier, make it much easier for us to do this. So give yourself a little bit of room here. In fact, maybe I will move this up to make it a little bit easier to write. And let's pull out the common terms. We had first said that there's a 2x. And there is also an x squared minus 1. Now, if we're going to factor this out, how many x squared minus 1s can we factor out? We look at the first one, and there's 4 of them, and in the second one, there's 3 of them. So we can only factor out the smaller number, the 3. So we're going to factor out an x squared minus 1 to the 3rd power. Now, we also know that there's an x squared plus 1, and again, in the first one, there's 4 of them. In the second one, there's 5 of them. So we can only take out the smaller number, 4 of them here. Now, this is going to be times everything that remains, everything else. Big set of parentheses out here. So now we go through each one first, each one by one. Here, we have x squared minus 1 to the 4th. X squared minus 1 down here. We factor 3 of them out, so there's 1 of them left. Once from the 4, we take 3 of them out, there's 1 of them left. So that's going to end up meaning that there's an x squared minus 1, well, to the 1st power. We don't have to write it. The 5 didn't get factored out, so it's still 5. The x squared plus 1, there's 4 of them, and we factored all 4 of them out, so there's none remaining. So that drops out. And the 2x we factored out here. So that must mean there's no, the 2x is already factored out, there's none there. So we're done with the first term, and we go on to the second term. We do the same thing. Of the x squared plus 1, there's 5 of them. The x squared plus 1, there's 4 of them. So 1 of them is left. The 4 was not factored out, so that remains there. The x squared minus 1, there's 3 of them, and all 3 of them were factored out. So we don't write that down. And of the 2x, well, that was also factored out here as well. So that is also be the same thing as 1, but we don't have to write that. So the second term becomes this. So now this makes our work easier. It's a lot of writing, yes. We're going to say, well, we have to keep writing this. X squared minus 1 to the 3rd. X squared plus 1 to the 4th. Now what we're going to do, give a little bit of this here so it's easier to read. We take the x squared minus 1 times 5. So that's going to give us 5x squared minus 5. Plus 4 times x squared plus 1. That's going to be 4x squared plus 4. Well, now we can combine like terms. So this is going to be 2x times the front part here. It's a little tedious, but we do need to write it. We don't want to forget any of them, of course, because we do need them in the answer. Now, we look at this and say, well, we have x squared. Here's 5x squared, and here's 4x squared, so it's 9x squared. And then we have minus 5 plus 4 is minus 1. Now, when we're doing this, I'm going to move the page up. When we're doing this, we realize that, well, we already have it simplified. And as far as I'm concerned, since we're business majors, not math majors, factoring it like this would be fine. Everything is simplified. We can take an x of most any number, and it's easy to do. If we took an x, if our x was 3, we could put them in each time, quickly calculate an answer. It's simplified. For those of you who looked at it and said, but wait a second, Greg, here, we have this 9x squared minus 1. Well, those are all perfect cubes, right? Well, yeah, so that gives us an idea that we can factor that. If you didn't see that last term factored it, I wouldn't demand it on an exam or any kind of quiz. But if you do see it, it is definitely correct to factor it. Again, I don't require it, but you can. Because this would factor down into 3x minus 1 times 3x plus 1. And maybe it's a little bit more of a thorough answer. And if we wanted to put things in a little bit more appropriate order, usually in math terms we do 2x times the 3x minus 1 times 3x plus 1, and then equations to the third power and equation to the fourth power. But I'm not that picky in this class. Again, we are business majors, and we're looking to get to an answer quickly. It doesn't have to be in 100% proper math form. But now hopefully from looking at this, we realize that, yeah, this is helpful to factor out things first, because if we multiplied this all out, how in the world would we find out that 2x is a common factor and all of these other ones are factors in there? It's easier to do it first, so we don't have to even do the work to start with. We factor it out before we multiply, and it's there. Now, this is an example of the product rule. And don't worry, working with the factoring out seems a little strange at first, but when you start doing the homework, it becomes pretty easy to do. And beyond that, it's basically just following a formula. Now, the quotient rule, again, is we're going to use this when we are dividing, hence the word quotient. So if we have one function divided by another function, an f of x divided by a g of x, then what we're going to do is this. It's going to be g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. Now, again, the shortcut way of writing this out would be gf prime minus fg prime divided by g squared. Now, looking at the quotient rule, hopefully it kind of makes sense why I said that some students like to memorize it, the product rule in the other order, because there it's the product rule is gf prime plus fg prime. And so then to memorize the two, you just remember that the first one, the product, when you're doing the product of two functions, it's a plus sign. And when you're doing the quotient rule, it's a minus sign, and you also have to divide by g squared. Now, this is, again, this is not too hard to do. It just takes a little bit of math and a little bit of factoring, but it's possible to do. Now, suppose that we wanted to find the derivative of this y function. Well, what we're going to need to do is, again, identify what our f and our g is. Now, that's pretty clear. Our f was always what was on top, and our g was what was on the bottom. So we're going to use this. This is our f and our g. Now I'm going to switch again back to the other utility, so I have more room for writing, but it's the same problem. So we identify that our f is x cubed, and our g is x squared plus 1 to the fourth power. Now, our f prime, of course, is going to be 3x squared, and our g prime is going to be 4x squared plus 1 to the third power times the derivative of what's inside, which is 2x. Now we can use our formula. That is the g f prime minus f g prime all over g squared. So that's going to be, our g is x squared plus 1 to the fourth, and our f prime, I can leave it the same color, our f prime is 3x squared, minus our f, which is x cubed, times g prime, which is 4 x squared plus 1 to the third, no, that's the third, so 2x, all over g squared. And our g is x squared plus 1 to the fourth, but this whole thing is squared. So we end up with this. I'm going to move the board up so I can continue writing. Now, when we look at this, then we say, wow, what do we have here? Well, one of the things we have here that we can factor out is an x squared. And with the x's over here, there's an x cubed and an x over here. So it's like it's x to the fourth. The 3 with the x squared doesn't factor into the 4 or the 2, so we have to leave it there. And of course, when we look at this, we realize we have an x squared plus 1 here and an x squared plus 1 here. And we'll see again, we have it down on the bottom, but that'll come into play later. We'll factor things out on the top first and then look at the overall picture. So if we were going to work with this, we're going to first realize that we can factor out our x's, and we can take out an x squared. There's 2 of them before the minus sign and 4 of them after. And we can also factor out our x squared plus 1. There are 4 of them before the minus sign, and there are 3 of them after, so we can only factor out the smaller number, the 3. And now there's no other terms that we can factor out, so we're going to need to multiply this by, and let's factor things out. Of the x squared plus 1, there's 4 of them, and we're factoring 3 of them out. So one of them is left, x squared plus 1. Now, if there's just one of them, make sure you put the parenthesis around the x squared plus 1, because they're not separate. If you're going to multiply this by something else, it has to be multiplied by both of them. For example, we have to multiply this by 3. The 3 didn't factor out. So if we did this so far, it would be 3x squared plus 3, not 3x squared plus 1 if we didn't put in the parenthesis, or x squared plus 3 if we didn't put in the parenthesis. So it's important, remember that. Now, the x squared of that function is factored out here, so we don't need that. Now it's going to be minus, and of the x's, we factor out 2 of them, so there's going to be 1 of them here. This may seem a little bit long, but I'm going to leave it this way, just so it's clear. There's 1 of them left there. The 4 didn't factor out. Of the x squared plus 1, the next term, the x squared plus 1, we factored all 3 of them out. There's 3 of them, we factored them all out, so that disappears. And there is a 2 here, so we have to have that. And there is still an x. We factored 2 of them out from this one to get an x, so this one stays here. In essence, there were 4 of them, x cubed plus times x is x to the fourth, so we should end up with an x squared. Some of you say, well, I saw that from the beginning. Couldn't I just write down x squared? Sure, that would be fine. In fact, even if you wanted to look at it and say, well, that's x squared and this is going to be 8x squared, sure, go ahead. But not all students like to do that, and I'm just doing it step by step. Now that we got that done, we have to remember with the product rule, after we factor all of that out, don't forget the denominator, the bottom number. It's easy to do when you get in a hurry, especially on a quiz or an exam. So here we have x squared plus 1 to the fourth power, all raised to the, all squared, I should say. So what's that going to be? Hopefully you remember your laws of exponents, and that means it's going to be to the 8th power. So it's going to be x squared plus 1 to the 8th power. Well, now, maybe this is a little bit neater if I put parentheses around there as well. Now we can multiply this together. I'm going to bump this up a little bit so easier to write. Move it down a little bit so I can see all of it. So this is going to be x squared times x squared plus 1 to the 3rd times, now here's we multiply the 3 times the x squared plus and the plus 1. So we get 3x squared plus 3. Now we're going to subtract. I'm going to keep the parentheses here just to make sure we don't miss anything. X times x is x squared. 4, that's going to be 8x squared. And this is all over x squared plus 1 to the 8th. Now, I left the parenthesis there. I kept them there just in case there was a second term, so I wouldn't forget to apply the minus sign. That's here to the second term, but in this case I may not have had to, but it's just safer to do. So, now in the next step, we can combine like terms that are in here. So, this is going to be x squared times x squared plus 1 to the 3rd, the 3x squared, and the minus 8x squared. I'm going to apply the minus 8 here. Is going to give us minus 5x squared. And it's going to be plus 3, and there's no units over here, so it's simply plus 3. All over x squared plus 1 to the 8th power. Now, when we do this, we look at it and say, you know what? It looks like we're done, but before you get done, look at the numerator and the denominator. Before, if we go back up to the top, when we pulled out common terms, I didn't mark it, but there is also an x squared plus 1 here. That is the same as the ones that are up top here. So that must mean that there are common terms down here. That again, we have, oops, there we go. We have the x squared plus 1 here, and we also have it on the top. So let's get rid of that. We realize when we're dividing, we can subtract the denominators. So there's 3 on the top, 8 on the bottom, all 3 of them disappear, and this one will become 5. So when we work with this, then we say, well, this is going to be x squared times minus 5x squared plus 3 all over x squared plus 1 to, oops, that's a funny thing, to the 5th power. And that's going to be our final answer. If you want to multiply it out, I won't necessarily mark it as wrong, but it's probably better to leave it in this case because it's more simplified. It is easier to find the answer this way. If you had to do, say x was equal to 3, it would be easier to do in this form versus multiplying it out. But either way, it's relatively simple. And I try not to be too picky. Now, back to our PowerPoint. When working with average cost, if we wanted to find the average cost of whatever we are producing, we know how to do that. But there's a little thing in here that can be helpful. If we're trying to find average cost, we would have some kind of cost function, a c of x. And then the average cost, by definition, is that the average cost is going to be equal to c of x divided by x. And I say, how does that work? Well, it's actually pretty simple. Think about it. If you wanted to find your average cost of producing 10 items, you do a cost of 10. X would be 10. So a cost of 10 items divided by 10. It's going to be our average cost. It's a simple thing. It's just simply putting it into calculus terms. Now, if we wanted to find out where our average cost is minimized, again, that's something that we are very interested in, minimizing cost. Well, what would we do? Well, we take our average cost and we would take the derivative of that. So the derivative of the average cost is going to be equal to the derivative of our cost function divided by x. Now, if we're doing this, to find the derivative of this, we need to use the product rule. And so we use the product rule, our g times f prime minus f times g prime all over x or g squared. And if we're minimizing it, we set it equal to 0. Now, we don't actually have a formula here, but let's look at these terms and figure out, well, if we were going to minimize this just with x, what would it be? Well, the first step would be to multiply both sides by x squared. That will cancel out the x squared in the denominator, and 0 times x squared is 0. So we would end up with x times c prime minus our cost function. Now, if we wanted to make this a little bit nicer, we could add our cost function to both sides, add c of x to both sides, and we get x times c prime equals c. Well, if we divide by x now, we would get c prime equals our cost function divided by x, which is our average cost function. So what this is telling us is that when our average cost is minimized, it is equal to our first derivative. It is equal to the marginal cost. Now, this does not mean that the marginal cost is always equal to the average cost. It is only equal to the derivative when the average cost is minimized. If you have if you had the functions and you plotted both of these, they would cross at one place, and that's going to be when the average cost is minimized. It'll equal the first derivative, the marginal cost. Now, I say that and I need to note the exception that if you have a straight line function, well, then you could actually have the average cost and the first derivative be the same all of the time. But again, usually we're talking with more complex things than that in working with production. So this can be just a little bit of a tip. The homework uses this. Don't assume that the average cost is equal to the first derivative and solve it that way. It won't work. When the average cost is minimized, then you can find the first derivative. And again, it's not going to be the formula, it's going to be the value. For example, if the average cost was minimized when x was 10, the value of c prime of 10 will equal the average cost of 10. That's what's happening there. Now, in using the average cost function, here's a problem. A wheat mill can produce X tons of flour per week at a cost of Great British pounds. Find the level of production where the average cost is minimized. Well, we know the average cost is c of x over x, so we find what c of x, well, we're given what c of x is. It's going to be x squared plus 1600 and divided by x. Now, to find the average cost minimization, we find the derivative of this and set it equal to 0 and solve. Well, this is, again, the the quotient rule. One function divided by another function. So we identify our f and our g, we find f prime and g prime, and we put it into our formula, and we get this kind of thing. Our g times our f prime minus our f times g prime all over g squared. Well, we set this, we can factor this down first off to make it a little bit easier. And when we do all of the arithmetic or the algebra with this, we're going to end up getting x squared minus 1600 over x squared. Now this we set equal to 0 if we are minimizing and solve for x. We're going to multiply both sides by x squared, and we get x squared minus 1600 equals 0. Of course, we're going to move the 1600 over to the other side and take the square root to get 40. And X is in, wheat mill can produce X tons of flour. So our unit is tons of flour. So we know that the average production cost will be minimized when we are producing 40 tons of flour. So hopefully this feels very familiar. It's simply taking what we've done a step further, taking our cost function and dividing it by X gives us our average cost function. And to minimize it, we take the first derivative, set it equal to 0, and solve. The homework for this lesson is this. Again, there are some challenge problems if you wish to do them. Naturally, you never have to do the challenge problems, but you can if you want. And this homework assignment is also on Moodle. So have a good day. See you in class.